All right, so for today's topic, we're going to be talking about integration, or what you may have heard called the antiderivative. So by this point, I'm assuming you know how to take your derivatives fairly well. So if you had something like f of x equals 5x cubed plus 2x minus 8, and say I took the derivative of this, we'd bring down the 3, using my power rule, we get 15x squared plus 2, and then of course the derivative of that negative 8 would just be 0 and it would disappear. Now imagine you were working in reverse. Imagine you were just given f prime and you were asked to figure out what you took the derivative of to get this. Well, that might be kind of difficult. So what you can start doing is just trying to think of, all right, what could I take the derivative of? You could think in that forward way. Is you could be like, well, I took the derivative here of x squared. I got x squared. So if I've got x squared, I must have taken the derivative of x cubed. And when I take the derivative of x cubed, I know that this 3 is going to come down. And then that might multiply by some number in front. And so if you thought about this for a while, as did those who invented or discovered calculus, you'd go, well, if the 3 comes down and I'm working in reverse, I'd want that to cancel off. So I'd have a third and then, well, times the number I have here, 15. So then I'd have my 15, the number I brought down would cross out, and then I'd have my x squared. And you'd have to carry on doing this. And keep in mind, this is just for these polynomials. It can get really confusing if you've got trig functions involved and stuff. So the antiderivative, or working in reverse, is given the name integral, and it looks like this. F of x is equal to the integral of f prime of x with respect to x. So when you see this, you're saying this, do the opposite process. Don't take the derivative, but undo the derivative and see what you get. Now something that's interesting as well is, say I throw this in here. So I'm doing the integral of 15x squared plus 2 dx. Now there's some integral rules, but for now I'm just going to rely on the way I was saying it here, that we're thinking in reverse. I know I need an x cubed, leave my number there, and then I'd have to cross out that third. Okay, I took the derivative of something and I got just 2. Well, whenever I take the derivative of just x, the derivative of that's 1, and I would just be left with whatever number's in front. But now something interesting happens. Notice this negative 8. When I took the derivative of that, it was just 0. What would have happened if instead of negative 8, this was positive 72, or negative pi, or plus e to the 7? All of those, remember e is just a number, all of those are just constants and they would just be 0. So how can I know which one of those is actually what belongs in my antiderivative? In fact, what if I had just plus 0 there in the first place? That still would have not changed the derivative, right? So what we do is we put plus c, where c is a constant. And again, that's because regardless of what that constant is, when I take the derivative, it would just go to 0. So there isn't really a way, if you're just doing an integral, to determine what this constant is. You'd have to be given some other information. But in general, the antiderivative, or the reverse process of taking the derivative, is called taking the integral. And how you do it is you just go term by term and you figure out what you took the derivative of, and then you add on a plus c. And so that is this topic video.